Now, what we've done so far is obviously exercises on permutations, exercises on combinations, and it worked out okay because we knew, oh, this is on permutations, this is on combinations. So the trick now, of course, is we're just going to get random questions in reality in a test. It's not going to say, this is a permutation question or this is a combination question. We've got to work it out. So just having a look at a few here from HSC. So 2007, Mr. and Mrs. Roberts and their 4 children going to a theatre that randomly allocated 6 seats in a single row. What's the probability that the 4 children are allocated seats next to each other? Permutation or combination? Yeah. This one will be a permutation because the actual order they're sitting in is important. So order is important. Okay. Probability. Well, there it is. 3 factorial, 4 factorial over 6 factorial. How do they get it? Well, the bottom of the fraction, of course, is no restrictions. So we're just arranging 6 people, 6 factorial. Top of the fraction, 3 factorial, 4 factorial. Okay. The 4 children need to be together in their one group. So that's the 4 factorial. Now, they're now one group, but they have to be, what was their... They simply had to be together. They didn't have to be in the middle, did they? No. So they simply had to be together. So we've now got the one group of the 4 children plus the 2 parents. So 3 objects altogether. And so that's where the 3 factorial comes from. And I think it's a 1 in 5 chance. 1 in 5 chance. Okay, actually this one comes from the Extension 2 paper of the same year. They do like asking these questions in Extension 2, but obviously they're a little bit trickier in Extension 2. So we've got a bag containing 12 red marbles, 12 yellow marbles, and we're going to pull 6 out without replacement. Probability that exactly 3 of those 6 are red. 3 of those 6 are red. This time it's a combination, because we're just pulling marbles out of a bag. We don't care the order they come out. We just want to know, okay, I've pulled all the marbles out. What's the chance 3 of them are red? Could have come out in any order. So it's a combination. So bottom of the fraction again would be total number, no restrictions. So the 24 marbles all up, I'm going to select 6. So 24C6 on the bottom. Now on the top, 12C3, 12C3. Why is it that? Well, I want 3 red marbles. So from the 12 red marbles, I'm going to choose 3. Still got 3 more to get, but now I can only choose from the remaining marbles that aren't red. In other words, the 12 yellow. So 12C3 for the yellow. Multiply together, and there's our answer, 0.36. Hence or otherwise, calculate the probability that more than 3 of the marbles are red. So hence means using what we've just done. So there must be a way of using that answer. It does say or otherwise. So I could go and work out more than 3 are red. I could go and work out 4 are red, 5 are red, 6 are red, add them all together. It has given me that option by saying or otherwise. So if I did it that way, probability 4 are red, well, 12C4, 4 from 12 of the red ones, but then I want 2 from 12 of the yellow ones. 5 red, 5C12 for the red ones, 1C12 for the yellow ones. 6 red, 12C6 for the red ones, and obviously I don't want any from the yellow ones there. And that gives us our final answer of 0.32. Okay, so we could do it that way. But what's more interesting is they said hence. So there must be a way of using the answer that we did before. And here's the way I could. Probability of greater than 3 red. If I use the complementary idea, 1 minus all the other possibilities. Now, one of those possibilities that 3 are red, another one is less than 3 red. Okay. But less than 3 red is the same as saying more than 3 yellow. So I've got less than 3 red ones, I've got more than 3 yellow ones. But more than 3 yellow would be the same as more than 3 red. Because remember, there were 6 red, 6 yellow. So that probability is going to be the same. And I've now got an equation. I can move that minus the probability of greater than 3 red to the left-hand side. And I get 2 lots of the probability of greater than 3 red is 1 minus the probability of 3 red, which is what I worked out in part I. And so half of that would be my answer. So half of 1 minus the answer we got for part I, and we come up with the same answer. So you still could have done it the other way, but this is the way where we could tie in the answer to part I. This is the hence solution. 2006 paper, chess match. So 2 teams, home team and away team, and there's 4 boards of chess being played. On each board, probably a home wins is 0.2, a draw is 0.6, home team loses, or away team wins, is 0.2. They then record the outcomes. So the example they've given us here is home team wins on board 2, that should be at board 1, shouldn't it? Home team wins on board 1, draws on board 2, loses on board 3, draws on board 4, they'd write down as WDLD. So win, draw, loss, draw. How many different recordings are possible? Okay, well, on each board, you could either win, lose, or draw. So there's 3 possibilities on each of the boards. 3 to the power of 4, 81. So that's possibly the gift mark of this question. So hopefully we'll pick that one up, fingers crossed. What's the probability that we end up with win, draw, loss, draw? Well, we know probability of a win is 0.2, probability of draw 0.6, and so on. So it'll be 0.2 times 0.6 times 0.2 times 0.6, 0.144. Okay. Now they make it a little bit more interesting. You get 1 point for a win, half a point for a draw, 0 points for a loss. What's the probability that the home team gets more points than the away team? Well, first thing I'm going to do is work out what's the probability that they get the same number of points. The same number of points. How could you get the same number of points? Well, if you had a draw on all 4 boards, you'd end up with the same number of points. So that's 0.1296. If I had 2 wins and 2 losses, you'd end up with the same number of points. 2 wins, 2 losses would be 0.2 squared, 0.2 squared, and then I've multiplied it by this 4 factorial on 2 factorial, 2 factorial. Because remember, I didn't say which board. So it's sort of like saying, how many words could I use using the letters W, W, L, L? And if I wrote those words down, that could become the arrangement of the boards. Each one of those would have the probability of 0.2 squared times 0.2 squared. So I end up with 0.0096. Is there another way we get equal points? And yes, there is. You can have 1 win, 1 loss, 2 draws. So this time it's 4 factorial on 2 factorial, because what we're now saying is win, loss, draw, draw. So WLDD, how many ways could you arrange WL and DD? 0.1728. I think that's it. I don't think there's any other possibilities. So the probability of equal points becomes 0.312. Now that's not what the question asks. If the probability of equal points is 0.312, then the probability of unequal points must be 0.688. Now in half of those, the away team must have more than the home team, and in half of those, the home team would have more than the away team. So my final answer would be half of that. So probability that the home team has more points, 0.344. Remember, this is extension 2 HSC. So even beyond the endpoint of extension 1, take it a bit further, you can get some really tricky questions there. So let's try another. Okay, pack of 9 cards, simply labelled 1 to 9. 3 are drawn at random, and we're just going to lay them down on a table. So if you like, we're creating a 3-digit number. What's the probability that that number will be greater than 400? Okay. Well, probability greater than 400 would be 6 in 9. How can I say that straight away? Well, it's all to do with the first digit. It really doesn't matter what the other 2 digits are. If that first digit is greater than 3, then I'll have a number that's greater than 400. So in other words, say, what's the probability of the first number? I wrote down greater than 4 there, but when you think about it, it should be greater than 3, shouldn't it? Because if the first digit is a 4, then your overall number is going to be greater than 400. But I think I still got the actual probability right. Around 4, 5, 6, 7, 8, 9, yeah, 6 ways. 4, 5, 6, 7, 8 or 9. So all right, with 2 or 3 chance of it exceeding 400. What's the probability that the digits are drawn in descending order? Descending order. Now, it doesn't necessarily mean 3, 2, 1 or 4, 3, 2. It might go 9, 6, 4. They don't have to be consecutive. They've just got to be going down. Well, I know there's 3 factorial ways of arranging 3 digits. Of those arrangements, of any combination of 3 digits you like, how many of those arrangements will the digits be in descending order? Yeah, there's only one way you could do it. Therefore, the probability is 1 in 6. Because it does not matter what the 3 digits are. There's only one way out of 6 that you could arrange those digits and they'd be in descending order. Alright, so we'll add 10H to the mix. As I say, I think that's a mixture of permutations and combinations, so you need to work out, what type of problem is this?